All right, welcome to this explainer, where we're diving deep into the fascinating world of AI agent architecture. Specifically, we're looking at how multi-tiered memory systems actually allow these agents to learn over time. We're going to completely unpack the exact under-the-hood mechanisms that take an artificial intelligence from being just a passive chat partner to a truly proactive, self-improving digital employee. It's a massive shift, and honestly, the architecture behind it is brilliant.
Okay, so here is our roadmap for today's explainer. We'll kick things off by moving beyond simple chatbots, then we'll break down the core agent loop, explore exactly how AI agents remember things, dive into the magic of self-modifying system prompts, and finally wrap up by examining cognitive agent architectures. Let's get right into it.
Section 1. Beyond simple chatbots, the paradigm shift.
So I want you to ask yourself, what actually separates the AI you just passively chat with from an entity that can autonomously go out and act on your behalf? You know, it's really easy to blur the lines here because sure, they both rely on large language models at their core, but their architectures, they serve entirely different purposes.
Think of it like this. A standard chatbot is basically a stateless brain relying on cloud auto memory. If you ask it for relationship advice 1 minute and then turn around and ask it to write landing page copy the next, you're risking a total cross-contamination of your context. It just gets confused. But a stateful agent, that's your digital employee. It's powered by a reasoning loop, it's equipped with literal tools it can use, and most importantly, it has explicit, user-controlled memory structures. You get total command over what it knows and exactly how it operates.
Moving on to Section 2. The core agent loop, which is all about observing, reasoning, and acting. Now we're looking at the engine itself. This is the react pattern in motion, and it's an incredibly powerful iterative cycle. First, the agent observes its environment. It's reading the context, scanning your files, looking at tool outputs. Then we hit the reason step. The LLM processes all that data to essentially think about the problem and plan its next move. And finally, act. It reaches out into the real world. Maybe it does a web search, writes some code, or just updates its own internal databases. It repeats this loop until the goal is absolutely nailed.
Section 3. How AI agents remember. Diving into the memory hierarchy.
You see, without memory, an agent is essentially a goldfish, right? It's forced to restart every single task completely from scratch. But with working memory, which actually functions a lot like our own human short-term awareness, the agent gets a temporary scratch pad. It can hold on to recent conversation history, current tool results, and active subgoals just long enough to complete whatever immediate task is in front of it. But once that task is done, the scratch pad gets wiped clean. So if we want to build an AI that compounds its value over weeks and months, we're going to need something much more permanent.
And that brings us to long-term retention. To pull this off, agents rely on two massive pillars, episodic memory and semantic memory. Episodic memory is all about past interaction trajectories. It remembers specific successes or failures, like exactly what steps it took to successfully fix that obscure bug for you last Tuesday. Semantic memory, on the flip side, acts as a factual knowledge base. It's the overarching encyclopedic vector database where the agent stores domain knowledge, company terminology, and tool docs. And researchers have actually shown that adding these specific memory tiers drastically improves an agent's success rate, especially when you throw complex enterprise tasks at it.
Section 4. Self-modifying system prompts. This is the persistent brain of the operation.
Okay, this is where things get really cool. Rather than relying on some hidden black box auto memory, you give the agent a persistent, self-updating system prompt. Think of an agents.mmd or a claude.md file sitting right in your project directory. This completely controls the agent's context. Before it even attempts to answer a single query, the agent loads up this document to literally remind itself of who it is, what your business does, and exactly how you like things done. The investor and builder Greg Eisenberg really hit the nail on the head with this concept. He says a good employee remembers preferences exactly and learns over time. Simple, right? But think about it. Just like a human hire, an AI agent's value absolutely skyrockets when it stops making the same annoying mistakes and actually starts compounding its intelligence based on your feedback. If you're constantly correcting your AI on the same formatting issue every day, well, it's not much of an assistant. But what if it could actually crack open its own rule book and rewrite it?
Well, let's look at that exact feedback loop in action. Say you ask the agent to build a website, and it defaults to dark mode. You correct it. You just say, hey, no dark mode. A basic chat bot fixes the code for that one session and forgets by tomorrow. But an agent, it actually opens its own memory file and permanently writes a new rule. Never use dark mode. So next week, when you start a completely fresh, brand new session, it reads that updated file first. Your preferences accumulate day by day, and the agent becomes highly, highly tailored to you.
Which leads us to Section 5, Cognitive Agent Architectures, specifically the Koala framework.
Because these agents are getting incredibly complex, researchers realized we need a unified blueprint to organize all this. Enter Koala, or Cognitive Architectures for Language Agents. Proposed by researchers at Princeton, this framework basically takes decades of cognitive science and classic 1980s AI architecture and brilliantly updates it to structure modern large language models. It gives us a rigorous, standardized way to map out exactly how an agent stores information and makes its decisions. What Koala does so well is it explicitly maps out the divide between internal actions and external execution. Before an agent actually does something out in the real world, which the framework calls grounding, it has to go through an internal planning phase. So it's essentially retrieving an episodic memory or actively learning a new rule entirely internally, just to make sure the external action it's about to take is the correct one.
So, breaking that action space down, you realize a true cognitive agent is doing so much more than just chatting. It's a dynamic cycle. It retrieves past knowledge from long-term memory, it uses LLM reasoning to process that data in its working memory, then, crucially, it writes or learns any new insights back into long-term memory. And finally, it takes a grounded action, like executing a Python script or searching the web. It's just a constant rolling loop of cognition. Now let's be totally real for a second. Fully autonomous loops, they can absolutely go off the rails sometimes. Agents today are amazing, but they aren't flawlessly reliable just yet. Giving them total unchecked autonomy can lead to errors that just compound on top of each other. And that's exactly why platforms like Microsoft's Magenotic UI are introducing these absolutely essential human-in-the-loop mechanics. By injecting tools like action guards and co-planning into the workflow, we are basically building a collaborative safety net. The AI becomes an extension of you rather than some rogue system. Agentic UI literally treats you as a member of the agent's team. The agent generates a multi-step plan, checks in with you to approve it, and it even streams its thoughts live so you can intercept it if it starts hallucinating. It'll actually pause and wait for your permission before doing anything risky. And the best part? Once you guide it to success, you can save that entire session as a shared memory skill for the agent to flawlessly reuse the next time. So as we wrap up and you think about these evolving, memory-rich architectures, ask yourself, how is having an AI employee that never forgets a single preference and constantly learns from your feedback going to completely redefine your productivity? We're moving rapidly away from tools that need our constant micromanagement toward true collaborative systems that observe, reason, remember, and act right alongside us. Thanks so much for joining me on this explainer. I'm going to leave you with one final thought. If your AI is going to perfectly remember everything you teach it starting tomorrow, what is the very first rule you're going to write into its memory today?